Hey, hello class. Got a question here for about number 42. And so let's read it together. It's from chapter 3, and it's a projectile motion one. So I'm going to begin with the same statement I've said a number of times. Cut your paper in half because nature behaves as if x and y are independent, so we've got to do our calculations separately and independent. And the other good thing is that the acceleration in the x direction is 0, and the acceleration in the y direction is negative 9.8 meters per second squared. So we know the acceleration and we know they're constant, so we could use any of those 5 constant kinematic equations, whichever one seems to be the most appropriate. And so let's read this one together. It says, suppose that a soccer player kicks the ball from a distance of 30 meters towards the goal. All right, so maybe I'll make a little soccer ball here. Maybe here's the pitch. We're going to take a shot, and the statement is we are 30 meters out. Okay, so soccer player kicks the ball at a distance of 30 meters towards the goal. Find the initial speed. Okay, so there's some initial speed. That's what we're looking for. The initial speed of the ball, if it just passes over the goal 2.4 meters above the ground. So maybe the goal extends up this high and it goes over the top of the goal 2.4 meters. Okay. Let me come back here. Where did I lost it here? Ah, there it is. Okay, so 2.4 meters above the ground. Given the initial direction is 40 degrees above the horizontal. All right. So we're talking about positions here. We are looking for initial speed. Sounds like we don't have anything involving final speed. So I'm going to go ahead and write out that second kinematics equation. And I'm going to do it for both x and y. All right, and now I'm going to start filling in. Also, as I mentioned, you should make sure you take a conscious effort to say, okay, where are you going to put your origin so you can measure things. And I'll just kind of put this in green at the launch point. Seems like the best choice. I can't imagine why anybody would pick anything different. So here's the launch point. And that given that it's a soccer ball, it's going to start on the ground, or at least near the ground. And so we'll treat those one and the same. I suppose we could maybe even add the diameter of the ball. But since they didn't explain it that way, I think the author picked the soccer ball so it would be on the ground. It's a little bit like sometimes the problem will pick a tennis player serving, and so the ball's way up in the sky, and so it is significantly higher. And then you could pick the origin where the ball is launched from, or you could pick the ground, and therefore the ball starts with some initial height. However, in this case, I'm saying all that because my next step would be put a 0 for the initial position, not only for x, but also for y. All right, so that's kind of step 1. Now, step 2, which we've done quite a few times, but I'm going to do it again and say, okay, if you're launching something with some initial speed, you can think of that as being made out of 2 different speeds instead of saying it is one speed at 40 degrees. We can say it's made out of a horizontal speed and a vertical speed. And for this type of problem, thinking of the two different speeds and realizing they're equivalent is really nice because, like I said, they only describe one speed and an angle, but we need to put them into our formulas as separate speed, a speed in the x and a speed in the y, because that's the way nature treats it. So this right here would be cosine of 40 degrees equaling the initial speed in the x direction over initial speed. And this, using sine of 40, would be the initial speed in the y. Okay, so that means up here, when it says what's the initial speed in the x direction, I can replace it with initial speed cosine of 40. And then I'll put a t, and then I'll put a plus 0. So that's 0 is from the 0 acceleration in the x direction. So maybe simplifying what I have so far, and going cosine of 40 degrees, I will put in the number 0.766 initial velocity times time equals x. And maybe I should put one more thing, since this is the mathematical equation of where it is on the x-axis. If I think about it now, what moment in time, based on that initial speed, would it be 30 meters over? So I'm going to put a 30 meters and then a 0.766 initial velocity times time. And if I then simplify that, so 30 divided by that last answer, looks like I'm at 39.16. So 39.16 is equal to the initial speed multiplied by time. And of course, that's two unknowns. So remembering from my algebra, I need two equations to solve for two unknowns. I really can't go any further. But just thinking about the x motion, you can see they gave me enough information, like how far does it go, 30, at what angle, 40 degrees, what acceleration, 0, what starting point. So they gave everything but 2, and that'd be the initial speed and the time. Okay? But I hopefully have a second equation that has those same two variables, and then of course it'll turn into a math problem where I have a system of equations, two unknowns, and hopefully they're the same two unknowns, otherwise it would be more than two unknowns. All right, so coming over to here, let's talk about the y motion. Now, I already said the starting position for the y would be 0, and as I started to work out here, then the velocity, initial velocity in the y direction would be initial velocity multiplied by sine of 40, then multiplied by time. And then, of course, over here, the acceleration is the negative 9.8, so that's why I'm going to put a negative. And if you'll go ahead and let me just take the 9.8 and multiply by 1/2, I'll get a 4.9. And now you can begin to see, if I put in the information that I have and say, okay, like we did for the x, I'm thinking of this time as when it went over 30 meters. I can think of this time as when it is at some height crossing the goal, which is 2.4 meters. I could also put in the decimal equivalent of sine of 40 degrees, which is 0.643. So 0.643 initial velocity times time minus 4.9 t squared. Okay. And I'll just leave that. I suppose we could do a little bit of division, but we got to decide. One of these we can divide out, but we're going to have the other one. So I'm just going to leave that alone and put a little box around it. But you can see that I have the same two knowns, initial velocity and time. So now it's going to turn into math. And so I'm going to jump over to a second page, but I've got a system of equations. And so I'll put my two equations here, and you can solve a system of equations in a lot of different ways. I'll just do the simple substitution. And so I'm going to start with the x and solve it for one of the variables, which would be t, and then use that t and plug it into the other one, all right? So plugging it into the other one, and I probably need a whole line here. So this would be the 2.4.643 V naught. Okay, and now I can put in my equation for time, which would be 39.16 over V naught. Then minus 4.9. And then t squared. Okay. And again, that's why I solve for t. So this would be 39.16 over V naught squared. So again, notice when I combine these two together, I have an equation that only has V naught in it, which I should, because I solved the first one for t and put it into the second one. There shouldn't be any more t's around. So now I should just have one equation with one unknown. So now it's just going to be a bunch of algebra. Fortunately, this first term has a V naught in the numerator and the denominator, so they cancel off. And so then I can just take this fraction that's still in my calculator and multiply it by 39.16 and get 25.17. And then this one is going to have a V naught squared on the bottom. Remember, the square means square everything in there, so the bottom and the top. So I got the V naught squared, but I'll also then have this 39.16 squared, and then of course multiplied by this 4.9 is going to give me some big number here. So 7,514.2. Maybe moving this to the other side, 7,514.2 over V naught squared would then equal 25.17. Moving this to the other side, minus 2.4. Why don't I just call that a 0.2? So when I do the subtraction, I guess I'll have to borrow and make that a 12. So a 12 take away 4 is an 8. And then a 4 take away 2 is a 2. And then the 2 take away nothing is a 2. So subtracting that, I get 22.8. You can think of that at 22.8 over 1 and then do our cross multiplication. All right, so the 7,514.2 times 1, and then the 22.8 times V naught squared. All right, so finally I'm there. I can take this 7,514.2. I can then divide it by the 22.8. That would be V squared. And so last step, taking the square root tells me that V naught would be 18 and 0.2 meters per second if we're looking at 3 sig figs. And I suppose you could argue that they only want 2 because they give a height of 2.4. They even give a distance of 30, although the question is that a significant figure or not? They also give an angle of 40, which again, 2 or maybe only 1, depending what they mean by the 0. So I'm going to assume they mean 2 and give an answer of 18 meters per second. All right, hope that helps.